In 1976, for the first time in history, a machine built by humans sat on the surface of another world and ran a test for life. It scooped up a pinch of red Martian soil, fed it a drop of nutrient, and waited to see if anything was alive to eat it. Almost at once, the instrument began to register a signal, a steady, rising count, exactly the shape you would expect if something in that soil was breathing. On Earth, this same test, with this same result, would have meant one thing: life. And then it got complicated. On the 20th of July 1976, NASA's Viking-1 became the first spacecraft to land safely on Mars and keep working. Minutes later, it sent home the first photograph ever taken from the surface of Mars, a black and white close-up of one of its own footpads resting on rocky, dust-covered ground. Color views of the rust-red plain, under a pale, dusty sky, came in the days that followed. A twin, Viking-2, soon touched down thousands of kilometers away. Each carried something no one had ever placed on another planet: a miniature biology laboratory packed into a box smaller than a kitchen oven, built to answer a single question: is there life on Mars? The most sensitive of its tests was called labeled release. The idea was simple and clever. Feed the soil a nutrient broth in which the carbon had been swapped for a radioactive tag. If living microbes ate that food, they would give off gas, and that gas would carry the tag, setting off a radiation counter. It was a way to listen for the breath of something alive. The lander dropped the nutrient onto a fresh scoop of soil, and the counter began to climb. A strong, clear rise, far above anything from the bare instrument. To be sure, the scientists ran a control. They took the same soil, heated it hot enough to sterilize it, to kill anything living, and repeated the test. This time, the signal was gone. Whatever produced it could be switched off by heat, just like life. Then, thousands of kilometers away, the second lander ran the very same experiment on its own patch of Mars. It gave the same positive result: two machines, two distant places, one answer that on Earth would have closed the case. By the textbook, this was the detection of life. But Viking carried a second, separate instrument, one that did not look for breathing, but for the bodies themselves. Its job was to search the soil for organic molecules, the carbon-based building blocks that every living thing on Earth is made of, and that even dead life leaves behind. It baked the soil and read what came off, and it found almost nothing. No organic molecules to speak of at either site. This was the impossible part. You cannot have life, busy, breathing, eating life that is built of nothing. A positive test for metabolism in a soil that appeared to be sterile. The two results could not both be simple, and they could not both be right in the obvious way. Faced with a signal that screamed life and a soil that showed no trace of it, the mission's scientists made a careful, conservative call. The breathing, they concluded, was most likely not biology at all, but some strange, unknown chemistry in the Martian dirt, a reactive soil that could eat the nutrient and release gas all on its own. No life required. Officially, Viking's search for life was ruled inconclusive. The needle had jumped, and the answer was filed away as probably not. But the man who had designed the labeled release experiment refused to let it go. Gilbert Levin had watched his instrument return the clearest positive it was built to give, twice, and he spent the rest of his life arguing that Viking had found life on Mars, and that the finding had been explained away too quickly. Most of his colleagues disagreed. He never changed his mind. He died in 2021, still insisting that the first life ever detected beyond Earth had been detected by his machine in 1976, and then quietly set aside. And then, decades later, Mars offered a clue that no one had in 1976. In 2008, a NASA lander near the Martian North Pole dug into the soil and found it laced with a reactive salt called perchlorate. That single discovery changed everything, because perchlorate does two things. Heated, it can destroy organic molecules, which means Viking's oven may have burned away the very evidence it was looking for, hiding any organics that were there. And it can drive strange chemistry that might, just might, produce a false breath of gas. The soil that looked sterile may not have been. The case, 50 years old, was suddenly open again. 50 years on, we still do not know. The Viking landers remain the only machines ever sent to Mars that tested directly for living metabolism. And they came back with a positive nobody has fully explained, and nobody has repeated. Every rover since has looked for water, for habitable ground, for the chemistry that could support life, but not one has run that simple, dangerous test again: put down food and see if the planet eats. The needle jumped in 1976, and half a century later, the most honest answer we have is still the one that should never satisfy us. We don't know.